Hello, myself Shubhashish Shah, Assistant Professor of Mathematics of Greater Kolkata College of Engineering and Management, GIS Group. In this video, I will discuss about beta and gamma function. So beta and gamma function is a special type of improper integration. First, I will begin with gamma function. Gamma function. Okay. So the gamma function is defined as gamma n equal to integration 0 to infinity e to the power minus x to the power n minus 1 dx, where n is greater than 0. So now we write it as gamma n equal to integration 0 to 1 e to the power minus x to the power n minus 1 dx plus 1 to infinity e to the power minus x to the power n minus 1 dx. You can see that this is an improper integral. So for this specific type of improper integration is called gamma function. Now we write this definition as this. We note that if n is less than 1, then 0 is a point of infinite discontinuity. 0 is a point of infinite discontinuity. Okay, and hence integration 0 to 1 e to the power minus x to the power n minus 1 dx is an improper integration. Integral having the integrand unbounded at 0. So therefore test convergence at 0 when n less than 1. Okay, so define fx as e to the power minus x to the power n minus 1 and gx equal to 1 by x to the power 1 minus n. Okay, now we are testing the convergence at 0 when n is less than 1. Now define fx and gx like this. Clearly, f and g both are greater than equal to 0 for all x belongs to open interval 0 1, and limit x tends to 0 plus, that is right hand side limit of 0, fx by gx will be equal to right hand side limit of 0 e to the power minus x and will be equal to 1. Hence integration 0 to 1 e to the power minus x to the power n minus 1 dx converges since integration 0 to infinity 1 by x to the power 1 minus n converges for n greater than 0. Now we test the convergence of this integral, that is 1 to integration 1 to infinity e to the power minus x to the power n minus 1 dx. So let phi x equal to 1 by x square. Okay, then phi x is greater than 0 for all x greater than equal to 1. Now limit x tends to infinity, fx by phi x equal to limit x tends to infinity x to the power n plus 1 y e to the power x equal to 0 for all n. Therefore, integration 1 to infinity e to the power minus x to the power n minus 1 dx is convergent as integration 1 to infinity 1 by x square dx converges. So combining these two results, we get that integration 0 to infinity e to the power minus x to the power n minus 1 dx is convergent for n greater than 1. Now I will discuss some important properties of gamma function. Okay. So first property I'll write is gamma of 1 equal to 1. Number 1. So the proof of this is very simple. From the definition of gamma function, we get gamma 1 equal to integration 0 to infinity e to the power minus x to the power 1 minus 1 dx, that is integration 0 to infinity e to the power minus x dx. Now this is equal to limit x tends to infinity integration 0 to x e to the power minus x dx, that will be equal to limit x tends to infinity minus of e to the power minus x 0 to x. Now limit x tends to infinity, it will be minus e to the power minus x plus 1, and since x is tending to infinity it will be 0, so the value of gamma 1 is 1, hence our proof. Okay. Next property number 2, gamma of n plus 1 equal to n gamma n. Okay. Now by definition of gamma function, we can write gamma n plus 1 equal to integration 0 to infinity e to the power minus x to the power n plus 1 minus 1 dx, that is integration 0 to infinity e to the power minus x to the power n dx. Okay. So it is equal to limit x tends to infinity 0 to x e to the power minus x to the power n dx. Now we will perform by parts integration to integrate this. So this will be equal to limit x tends to infinity x to the power n minus e to the power minus x minus integration x to the nx to the power n minus 1 e to the power minus x, and this will be plus. Okay. This will be 0 to x, this will be 0 to x. Okay. Now this is equal to limit x tends to infinity minus x to the power n e to the power minus x plus n limit x tends to infinity 0 to x to the power n minus 1 e to the power minus x dx. And this will be equal to 0. This will be equal to 0 plus n limit n tends to infinity, x tends to infinity 0 to x to the power n minus 1 e to the power minus x dx. And this is n into, by definition of gamma function, okay, first we write it as 0 to infinity x to the power n minus 1 e to the power minus x dx, and you can see that this is the definition of gamma n. So this is equal to n gamma n. Okay. So So we see that gamma of n plus 1 equal to n gamma n. Now from this result we can derive another result. Since gamma of n plus 1 equal to n gamma n, similarly we can write gamma n equal to n minus 1 gamma n minus 1, and similarly we can write gamma n minus 1 as n minus 2 gamma n minus 2. This will be equal to n minus 1 into n minus 2 into n minus 3 into gamma n minus 3, and continuing in this way we'll get n minus 1, n minus 2, n minus 3 dot 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 up to 1 gamma 1. And since gamma 1 equal to 1, we have proved this in the previous result, so it will be n factorial. So gamma n plus 1 is also n factorial. Okay. Okay, so gamma n plus 1 equal to n gamma n. This will be n into n into n into n. This will be n factorial. Now I'll go to next property. Okay, before going to next property, first I'll remove this. Property number 3, for any a greater than 0, integration 0 to infinity e to the power minus ax, x to the power n minus 1 dx equal to gamma n by a to the power n. So the proof is, let us assume ax equal to y, then dx equal to 1 by a dy. Now limit will not be changed, limit will be same. It will substitute, it will be 0 to infinity e to the power minus y, sorry, x means y by a whole to the power n minus 1, and dx will be 1 by a dy. So it will be 1 by a to the power n integration 0 to infinity e to the power minus y, y to the power n minus 1 dy. So it will be 1 by a to the power n gamma of n. So hence our proof. Okay. And next property, for 0 less than m less than 1, gamma m into gamma 1 minus m equal to pi cosec m pi. Okay. So these are the 4 important properties of gamma function. Next I will go to beta function. I will discuss for beta function. After discussion of definitions and properties, I will solve some problems of these two functions. Okay. So next function is beta function. Beta function is also a special type of improper integral. Beta function. So the beta function is defined as beta mn equal to integration 0 to 1 x to the power n minus 1 1 minus x whole to the power n minus 1 dx, where m and n greater than 0. Now we note that if m and n are greater than equal to 1, the beta function is a proper integral. But if m less than 1, n greater than equal to 1, then it will be proper integral. Okay, and if m is less than 1, then 0 will be a point of infinite discontinuity, and if n is less than 1, then 1 is a point of infinite discontinuity. M less than 1, then 0 will be a point of infinite discontinuity, and if n is less than 1, then 1 will be a point of infinite discontinuity. So for m and n less than 1, we will check the convergence. So let m less than 1 and m less than 1. So integration 0 to 1 x to the power m minus 1 1 minus x whole to the power n minus 1 dx equal to integration 0 to half x to the power m minus 1 1 minus x whole to the power n minus 1 dx plus half to 1 x to the power m minus 1 1 minus x whole to the power n minus 1 dx. Now to test the convergence of the first part at x equal to 0, we take fx equal to x to the power m minus 1 1 minus x whole to the power n minus 1 and gx equal to 1 by x to the power 1 minus m. We observe that f and g are greater than 0 for all x belongs to open interval 0, half, and right hand side limit of 0 x tends to 0 plus fx by gx equal to limit x tends to 0 plus 1 minus x whole to the power n minus 1 equal to 1. Hence integration 0 to half x to the power m minus 1 1 minus x whole to the power n minus 1 dx converges as integration 0 to half 1 by x to the power 1 minus m converges for m greater than 0. Next we test the convergence of half to 1 x to the power m minus 1 1 minus x whole to the power n minus 1 dx at x equal to 1. Okay. So to check the convergence, we take fx equal to x to the power m minus 1 1 minus x whole to the power n minus 1 and gx equal to 1 by 1 minus x whole to the power 1 minus n. Clearly f greater than 0, g is greater than 0 for all x belongs to half comma 1 and limit left hand side limit of 1 extends to 1 minus fx by gx equal to limit x tends to 1 minus x to the power m minus 1 will be equal to 1. Hence integration half to 1 x to the power m minus 1 minus x whole to the power n minus 1 dx is convergent since integration half to 1 dx by 1 minus x whole to the power 1 minus n is convergent for n greater than 0. So combining the previous and this result, we get that integration 0 to 1 x to the power m minus 1 1 minus x whole to the power n minus 1 dx is convergent for m greater than 0 and n greater than 0. So now I will discuss some important properties of beta function. First property, number 1, beta mn equal to beta mn. So beta mn, by definition of the beta function, we know that integration 0 to 1 x to the power m minus 1 into 1 minus x to the power whole to the power n minus 1 dx. Okay. Now if we put 1 minus x equal to z, then minus dx equal to dz, and when x will be equal to 0, z will be 1, x will be 1, then z will be 0. So it will be 1 to 0, x equal to 1 minus z to the power n minus 1, z to the power n minus 1, and dx is minus dz. So changing the limits, you get 0 to 1, z to the power n minus 1, 1 minus z whole to the power m minus 1 dz, and this will be beta of n comma m. So beta mn is same as beta nm. Now property number 2, beta mn equal to integration 0 to infinity x to the power m minus 1 by 1 plus x to the power m plus n dx equal to integration 0 to infinity x to the power n minus 1 by 1 plus x whole to the power m plus n dx. Now beta mn equal to integration 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. By definition we can write it, let x equal to 1 by 1 plus y, then dx will be minus of 1 by 1 plus y whole square dy, and when x equal to 0, y equal to 1, and x equal to 1, y equal to half. No, sorry, when x equal to x equal to 0, when x equal to 0, sorry, when x equal to 0, y equal to infinity, and x equal to 1, y equal to 0. Okay. So beta mn equal to okay. Let us remove this. So beta mn equal to minus integration infinity to 0 1 by 1 plus y 1 by 1 plus y whole to the power n minus 1 into y by 1 plus y whole to the power n minus 1 into minus 1 by 1 plus y whole square dy. And this is equal to integration 0 to infinity y to the power n minus 1 by 1 plus y whole to the power n plus n dy. Okay. Since beta mn equal to beta nm, we proved this radius in the previous lesson, then beta mn equal to integration 0 to infinity x to the power n minus 1 by 1 plus x whole to the power n plus n dx equal to integration 0 to infinity x to the power m minus 1 by 1 plus x whole to the power m plus n dx. So hence the proof. Next, property number 3, beta mn equal to 2 into 0 to pi by 2, integration 0 to pi by 2 sine to the power 2n minus 1 theta to cos to the power 2n minus 1 theta d theta. Okay. And from the definition of beta function, we get beta mn equal to integration 0 to 1 x to the power m minus 1 to 1 minus x whole to the power n minus 1 dx. Let us put x equal to sine square theta, then dx will be 2 cos theta sine theta minus d theta. And this will not be minus. When x equal to 0, then theta will be 0, and x will be 1, then theta will be pi by 2. So beta mn equal to 0 to pi by 2, x to the power n minus 1 means sine to the power 2m minus 2, 1 minus sine square theta, that is cos square theta, to the power n minus 1, that is 2n minus 2 theta, dx equal to 2 cos theta sine theta d theta. So it will be 2 into 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta. Okay. So note that beta of half comma half, that is if n equal to half and n equal to half, then it will be 2 into 0 to pi by 2 sine to the power 0 theta cos to the power 0 theta d theta, that is 2 into theta 0 to pi by 2, that will be pi. So beta half comma half is equal to pi. Okay. Next, I'll go to next property. the relation between beta and gamma function. Property number 4. The relation between beta and gamma function. So beta mn equal to gamma n by gamma m plus n, and gamma half equal to root 2. So we know that beta half equal to pi. So gamma, applying this result, gamma half by gamma of 1 equal to pi, and gamma half whole square, that is gamma half whole square is equal to pi, since gamma of 1 equal to 1. We have proved this before. Then gamma half will be root pi. Okay. And the next property number 5, beta of p plus 1 by 2 comma q plus 1 by 2 equal to 2 into integration 0 to pi by 2 sin to the power p theta cos to the power q theta d theta. Okay. So the proof is beta of p plus 1 by 2 comma q plus 1 by 2 is equal to, by the relation between beta and gamma function, we can write gamma p plus 1 by 2 gamma q plus 1 by 2 by gamma of p plus 1 by 2 plus q plus 1 by 2. Okay. And p comma q greater than minus 1. So from the property number 3, that is beta mn equal to the relation between the sin beta mn equal to 2 into 0 to pi by 2 integration 0 to pi by 2 sin to the power 2m minus 1 theta cos to the power 2n minus 1 theta. We can write beta mn equal to 2 into integration 0 to pi by 2 sin to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta. So let us put 2m minus 1 equal to p and 2n minus 1 equal to q. Then m equal to p plus 1 by 2 and n equal to q plus 1 by 2. So beta of p plus 1 by 2 q plus 1 by 2 equal to 2 into integration 0 to pi by 2 sin to the power p theta cos to the power q theta d theta. So 2 into 0 to pi by 2 sin to the power p theta cos to the power q theta d theta. So hence the proof. Note that integration 0 to pi by 2 sin to the power p theta cos to the power q theta d theta equal to half into beta of p plus 1 by 2 q plus 1 by 2 is equal to, applying the relation between beta and gamma function, we can write half into gamma p plus 1 by 2 gamma q plus 1 by 2 by gamma of p plus q plus 2 by 2. Okay. Now I will discuss the last property of beta function. Property number 6, for m greater than 0, 2 to the power 2m minus 1 gamma m plus half equal to root pi gamma of 2m. So from the definition of beta function we get beta mn equal to gamma m by gamma of m plus n. Okay. And is equal to 2 into integration 0 to pi by 2 sin to the power 2m minus 1 theta cos to the power 2m minus 1 theta d theta. So for n equal to m, beta mn equal to gamma m by gamma of m plus n, that is 2 into integration 0 to pi by 2 sin to the power 2m minus 1 cos to the power 2m minus 1 theta d theta. So it is equal to 2 by 2 to the power 2m minus 1 integration 0 to pi by 2 2 sin theta cos theta to the power 2m minus 1 d theta, and it is equal to 2 by 2 to the power 2m minus 1 integration 0 to pi by 2 sin to the power 2m minus 1 2 theta d theta. Now we can write this as 2 by 2 to the power 2m minus 1 integration 0 to pi by 2, sorry, it will be 2m minus 1 integration 0 to pi by 2 sin to the power 2m minus 1 phi d phi by 2, where we have substituted 2 theta by phi, and this is equal to 1 by 2 to the power 2m minus 1 into 2 integration 0 to pi by 2 sin to the power 2m minus 1 phi d phi as f of a minus x equal to fx. Okay. Next, we put a equal to half, then we get beta m comma half equal to gamma m gamma half by gamma m plus half equal to 2 into integration 0 to pi by 2 sin to the power 2m minus 1 theta d theta, that will be equal to gamma m by gamma 2m into 2 to the power 2m minus 1, using the previous equation, using this. Okay. So gamma m gamma half by gamma m plus half equal to gamma m by gamma of 2m 2 to the power 2m minus 1. So gamma m into gamma of m plus half to 2 to the power 2m minus 1 equal to gamma half to gamma of 2m or 2 to the power 2m minus 1 gamma of m plus half equal to gamma half is root 5, we know, we have proved this, root 5 gamma 2m. Okay, so this was all for this video. I have discussed the definitions of beta and gamma function and all the basic properties of beta and gamma function. Now in the next video I will solve some problems of beta and gamma function. You watch this video. If you have any query or question regarding this video, you can contact me. My contact details is given the first slide of this video. Thank you.